Assalamualaikum warahmatullahi wabarakatuh. So this is our project one that we have done, titled Sustainable Product. This project one is for our lecturer, Dr. Muhammad Wahizat bin Muhammad Rashid, lecturer for ECS 246 Civil Engineering Materials. So let we introduce ourselves. My name is Amni Izzati binti Muhammad Aziz with my group mates Muhammad Amirol Arif bin Muhammad Lotepi, Nurul Asyikin binti Muhammad Ghazi, and Nurhazwani Husna binti Muslim. So this is the contents in our slide. So the first thing is introduction. So what is concrete? So concrete is a construction material composed of cement, fine aggregates, which is sand, and coarse aggregates mixed with water, which hardens with time. There are different types of concrete that exist in the world for a number of uses. So this is some of the types of concrete, which is number one is modern concrete, most commonly used regular concrete created by mixing Portland cement, and number two high strength concrete, which is different from normal strength concrete in the amount of force it can resist without breaking. Number three is high performance concrete, which is include a high compressive strength. Other characteristic used to define high performance are the ease of placement without affecting strength and toughness. And the last one is ultra high performance concrete, which is particularly durable because of the combination of fine products. So we continue with what is sustainable concrete. So a sustainable concrete structure is constructed to ensure that the overall environmental impact during its life cycle, including its use, is minimal. Sustainable concrete is expected to have a very low inherent energy requirement to be produced with little waste, to be made from some of the most abundant resources on Earth, to produce durable structures, to have a very high thermal mass, and to be made from recycled materials. Sustainable construction has a small impact on the environment because they use green materials with low energy costs, high durability, low maintenance requirements, and a large proportion of recycled or recyclable materials. So the construction industry is more impacted than any other sector by the ongoing sustainability debate. This is primarily due to the pronounced environmental impact associated with the manufacture of building materials, the erection of buildings, because the manufacture of this material, and in particular the manufacture of its raw material cement, is highly energy intensive and causes high CO2 emissions. Nonetheless, that the environmental effect during concrete manufacturing without considering the effects on the material's efficiency and longevity does not suffice, as the lifetime expected of concrete structures usually varies from 50 to 100 years and therefore spreads the impact on the environment over a long period of time. Therefore, increasing the sustainability of building structures requires both a reduction of the environmental impact associated with the processes of erection, maintenance, and operation, in conjunction with an increase in the structure's durability at maximum technical performance. So this relation is detailed as equation below, which is building material sustainability is equal to lifetime performance over environmental impact. So according to the equation, there are three fundamental approaches for the sustainable use of concrete. For number one, optimizing the concrete's composition in the light of its environmental impact while maintaining equal or better performance and lifetime. Second, improving concrete efficiency with equal effect on the climate and on lifespan. And the third one is optimization of the building materials lifetime and the building structures with equal environmental impact and performance. Into account in this research project for sustainable development of concrete construction works in the world. So for the number one, the objective is causes of deterioration of concrete structures. Next, problems at construction site effects that causes early deterioration of concrete structures, quality of cement blends, properties of concrete made with various aggregates, recycling of demolished concrete as coarse and fine aggregate for new construction, use of recycled fine aggregate, which is less than 5 mm in size for making concrete blocks, development of permeable concrete for special application, determination of carbonation coefficient in natural exposure conditions, and the last one is the application of recycled and permeable concrete and long-term exposure tests. So that's all for the introduction for sustainable product. So next we are going to continue with the method. I will pass it to Nurul Asyikin.
Thank you, Amni. So I am Nurul Asyikin binti Muhammad Rozi and I will explain about methods. We are using two articles to explain about methods, which is Design and Properties of Sustainable Concrete. The other article is Analysis of the Causes of Failure of a Story Building. Is eco-balance method that we found from Design and Properties of Sustainable Concrete. The objective of the method is to produce the sustainable concrete by considering the impact of performance and durability of the material and reducing the environmental impacts. So how they are producing the sustainable concrete with the method. The first one is reduce the amount of binder in producing concrete. The second one, produce concrete with average compressive strength, which is 30 megapascal, where cement was replaced with reactive additives such as fly ash or slag and stone powder. And other than that, replace the Portland cement with limestone powder, fly ash, and composite cement to maintain the strength and durability of concrete. And finally, is using packing algorithm like compressible interaction packing model, which is CIPM, by reduce the amount of cement clinker needed for the production of concrete with regard not only to the building material but also to the building structure. For the pros and cons of eco-balance method, the first advantage of the method is it can extend the strength and durability of material. The second one, it can reduce CO2. The third one, it can extend the operational life of concrete. For the disadvantage of the material, we know that the method is expensive because we need high technology in producing the sustainable material. The second one is more time needed in producing, because we know that we need to find a very high quality of material in producing good quality of sustainable material. For the third one is skilled operator is required for operational, because we have a high quality of material and high technology, so we need to have skilled operator to produce the sustainable material. For the second method, which is non-destructive test, which is cube compressive test, the objective of the test is to determine any material strength characteristic. How they conduct the test: first of all, remove the specimen from the water after specified curing time and wipe out excess water from the surface. Take the dimension of the specimen to the nearest 0.2 meter. Clean the bearing surface of the testing machine. Place the specimen in the machine and then rotate the movable portion gently by hand so that it touches the top surface of the specimen. Apply the load gradually without shock and continuously at rate of 140 kg cm squared per minute until the specimen fails. Record the maximum load and note any unusual features in the time of failure. Pros and cons of non-destructive test, which is cube compressive test. The first advantage is long-term use with high reliability and free maintenance. Second one is low noise during test. The third one is the control process is not affected by temperature, and the performance is more stable. For the disadvantage, the result is not accurate as cylindrical specimen. The second disadvantage is the result not obtained immediately because we need to wait for 7 days, 14 days, 21 days, and 28 days. And then the strength properties of a concrete specimen depend on its size and shape. As I mentioned before, the cylindrical specimen is more accurate than cube specimen because the size and shape of the specimen can affect the result.
Assalamualaikum, I'm Nurhazwani Husna binti Musalim and I'll continue the presentation on findings. So this is table 1. Table 1 is based on method 1, which is eco-balance method. So table 1 is showing the impact categories classification, the environmental impact of industrial processes. The first column is category and the second column is designation and the last one is unit. The first category is CED fossil, which stands for cumulative energy demand non-renewable. The unit is in joule. The second is also CED, but it is renewable. It stands for cumulative energy demand. It is renewable, and the unit is joule. The next one is GWP, global warming potential, kg CO2 equivalent. Next is ODP, ozone depletion potential, kg RII equivalent. And then it is AP, acidification potential, kg SO2 equivalent. NP, nutrification potential, kg PO4 equivalent. And the last one is POCP, photochemical ozone creation potential, kg C2H4 equivalent. The impact every substance emitted into the environmental hereby can be attributed to of the 7 impact categories which have been internationally agreed. The environmental impact resulting from the production of 1 meter cubic of concrete can be calculated by multiplying the impact resulting from the production of each raw material with the amount of raw material used in the concrete and by summing up the individual impacts. Now, let us continue with table 2. Table 2 is based on method 2, which is non-destructive test, cube compressive test. Table 2 is showing the cube compressive strength test for 7, 14, 21 and 28 days. The first column is curing age in days, second is weight in kilogram, and the last one is average compressive strength in Newton per millimeter squared. The first curing age is 7 days. The weight that it gained is 8.42, 8.05, 8.61 and the average compressive strength is 15.7. The second curing age is 14 days, which is 8.20, 8.52, 8.46 in weight and 7.3 for average compressive strength. The third is 21 days, 7.99, 8.74, 8.32 and the average compressive strength is 22 Newton per millimeter squared. The last one is 28 days. The weight is 8.95, 8.78 and 8.94 and the average compressive strength is 26.5 Newton per millimeter squared. The design mix of 1 to 4 used in the casting of the collapsed building. The result from the strength test has confirmed that the design mix and the materials are in a good quality because the average of the compressive strength is 26.4 megapascal. That's all from me, and now let's continue on discussion by Amirol.
Thank you to Hazwani for the presentation. I will continue the presentation with discussion. Based on the research that we use for this project, the research very helping to our group know the methods of sustainable concrete testing. There no have any limitation of knowledge during process of this project. From the finding that we get from the method, from the research, the compressive strength of concrete increasing day by day until the concrete all set and dry. The accuracy of the result is very high and the result is very convincing and logic. We do not have any unclear aspect from this research work because of the research already complete with methods and knowledge of sustainable concrete. This study can contribute to the development of future sustainable products by finding new research on new sustainable materials that can be used for future construction with long-term use and low in cost.
Thank you, Amirol, for the discussion. Hi, I'm Hazwani, and I'll continue with the conclusion. Based on the articles that we've studied, we learned that before starting a construction, it is important to make sure that the materials that are being used are sustainable. It is to prevent from accidents that harms other people's life, as sustainable material usually have better strength than normal materials. Next, sustainable of material is not just important for the strength of construction, but also the impact that will be given to the environment at the site. Sustainable material is usually eco-friendly, so it will give good impact to the environment. And the last conclusion is sustainability of material is also important in making sure that the project has quality but also follow the client's budget. So that's all from us. So these are the references that we use. So mostly of the references that we use are from the internet. So that's all from us. Thank you for watching.